So what should we do when we have a model including too many variables, or when we want to include more variables than that is allowed to? First, check if we can drop some clinically less important variables, especially ones with many missing observations. And I didn't talk about missing observations. And when you fit the multivariable regression, you need to be careful. And the data included in multivariable regressions are complete data. So for example, if you include 10 variables, independent variables, and if there is a patient and who is missing, for example, triglyceride value, but have everything else, and entire data for that patient would be excluded from the model. Be aware when you compute number of variables you can include in the model, and you need to know how many patients do not have a missing value. So you think you are including 100 patients, but if you check the model really, you may be including only 30 patients, and 70 patients are deleted because of the missing observation. And number 2, check multicollinearity. Drop correlated variables, and 2, combine correlated variable into one variable. So in this part of video, I will show you how to check multicollinearity to identify correlated variables, and how to combine those correlated variables into fewer number of variables using mathematical technique called factor analysis. Okay. And then number 3, try to combine variables into propensity score. So next part of video, and I will talk about how to conduct propensity score analysis. So let's talk about diagnosis of multicollinearity. Let's start with multicollinearity diagnosis. So because logistic regression does not have a multicollinearity diagnosis option, we use linear regression for this. And multicollinearity is correlation among independent variables. Calculation doesn't involve outcome variable. Therefore, form of regression does not matter. And form of regression depends on type of outcome. So we use linear regression option because it has nice feature of checking collinearity. Okay, so let's go to SPSS. Okay, so we go to linear regression, and dependent variable can be whatever. So we put the calcium, and then let's include all variable we want to put in the model. Okay, and then you click on statistics, and here is a button called linearity diagnosis. Okay, continue and OK. And you go to this table of coefficient, and by clicking the collinearity button, it added 2 columns. One is VIF, it's the variance inflation factor, and the other is tolerance. So here you can see VIF for cholesterol, HDL, LDL, triglyceride are much larger than other variable. And when the VIF is greater than 2.5, it indicates multicollinearity. And tolerance is 1 over VIF. So you could use tolerance less than 0.4 indicating multicollinearity. It's the same thing. So now our challenge is how to avoid multicollinearity. Problem with multicollinearity is when the correlations are so strong among independent variables, it will make model unstable. So p-value tend to get larger, standard error tend to get too large. So therefore it called the variance inflation factor. Standard error is the similar term to variance. And if you check Spearman's correlation on any pair of these variables, and you can get intuitive sense in terms of correlation. So HDL correlate with cholesterol with correlation coefficient 0.4. LDL cholesterol correlation is 0.9. Triglyceride to cholesterol correlation is 0.4. It's all statistically highly significant. So the easiest way to avoid the problem of multicollinearity is to pick only one variable out of these four. Okay, and you may do that based on your clinical judgment. But there are many situations. You might say, well, these four are correlated, but they measure a third of different things. So I want to include all four variables in the model. And then when that is the case, the solution is to combine these correlated variables. And that's when we use factor analysis. So let me show you how to conduct factor analysis to combine these four variables. So you go to dimension reduction, factor, and we put these four variables, okay, and click on scores, and we want to make sure new scores will be created and pasted into working data set. Okay, click continue, and then go ahead to click OK. Okay. So factor analysis created two new variables, and these called, I go to data set, factor 1 and factor 2. Okay, and these factor 1 and factor 1 explain 59% of variation existing in all four variables combined, and factor 2 explain 28% of variations among these four variables. And factor 1 and factor 2 are independent to each other, therefore with both variables, and it can explain 84% of variation among these four factors. And if you wonder how each factors are related to original four variables, and you can see this component matrix, and higher the number indicate each variable correlate with a new factor. So cholesterol, LDL, and triglyceride correlate with factor 1, and although factor 2 is more from LDL, HDL, and triglyceride. So in order to proceed, and we redid variance inflation checking using these two new factors, factor 1, factor 2. And then we don't see a large VIF anymore. So therefore, we don't have to worry about multicollinearity. And so let's refit binary logistic regression with these two factors. So we are now able to say that effective SLE was adjusted also for cholesterol, LDL, HDL, triglyceride through two uncorrelated factors which combine the four correlated variables. Though, as you may have realized, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 variables, and we know we can include only up to 2 variables. So this model is still overfitted. So what should I do? And next solution is, how about try to combine variables into a propensity score? So there is a method you can collapse all these covariates into a one score, and I will explain this in the next video.